This is question number 1. Psi star psi has the unit of dash at the point x comma y comma z. Okay, what is the unit of psi star psi at x comma y comma z? See, listen. At x comma y comma z means it is three-dimensional space. In 3D space, okay, psi star psi, this will give you probability density. What is density? Mass by volume. This is probability density. Okay, probability per unit volume, that's the meaning. So since it is per unit volume, the unit of this quantity psi star psi, right, is equal to volume inverse. It may be liter inverse or meter cube inverse, right? Any volume unit, volume inverse unit. Okay, but keep this in mind. Psi star psi d tau. If you multiply psi star psi with the d tau is the volume element. This the unit of d tau is v, volume, and this is per 1 by v. So 1 by v, they cancel each other. Therefore, psi star psi d tau, it gives the probability in small volume element d tau, which is actually no unit. It has no unit. Okay, keep this in mind, very, very important. Okay, see what I am trying to say. Psi star psi has the unit of 1 by volume, whereas the quantity d tau has the unit of volume. So we cancel. Therefore, it is dimensionless quantity. Psi star psi d tau is dimensionless, whereas psi star psi has volume inverse unit. In 3D space, if you come to 1D, in 1D, okay, what is meant by psi star psi? Psi star psi has the unit of length.
Inverse.
Yes, it has the unit of length inverse. Okay, take 2. Correct option for this question is option C. Okay, take 2. So, in question number 2, what is asked here is, for a quantum mechanical system, you know very well, quantum mechanical system means microscopic particle. It can be electron or proton or atom or a molecule. Okay, so for a quantum mechanical system, potential energy V is independent of time. It is given that potential energy is independent of time. Then the square modulus of psi x comma y comma z comma t is equal to. Here this is very, very important one. Listen, 2. Since volume is independent of time, it is given that volume is independent of time. Okay, the total wave function psi, which depends on x, y, z as well as time, you can separate this into 2 parts. One depends only on coordinates x, y, z. The other one depends on time f of t. See, this separation is possible if potential energy is independent of time. Okay, now what is square modulus of psi? It is nothing but psi star psi. Okay, and you know very well psi x comma y comma z into the time part. Okay, the value of time part is e power minus I e t by h cross. E power minus I e t by h cross. This is a formula for time part. Okay, now listen. What is square modulus of psi star? Listen, psi x comma y comma z t square modulus of the wave function, right? It can also be written as psi star psi. Psi star into psi. It's nothing but psi star psi. Okay, what is psi? What is psi? This is psi. This is psi. So I'll write this once. Psi x comma y comma z into e power minus I e t by h cross. Okay, this is psi.
The e power minus I e t by adu eppadi sir vandhathu?
Yeah. Listen. Yes, you are right. Listen, so I'll just explain again. See, the total wave function, see what is given here, wave function depends on coordinate as well as time. So square modulus of this wave function is nothing but finding probability. Finding probability at this point at time t. Correct? But since potential energy is independent of time, you can separate the total wave function into two parts. One part depends only on coordinate and the other part depends on time. And if you solve the equation, Schrödinger equation, the time part comes out as e power minus IAT by h cross for all system if potential energy is independent. Okay, time part is always e power minus AT by h cross for all system if potential energy is independent of time. Okay, now see, I have the total wave function, the given wave function actually depends on time. Now I separated it into two parts. One part is time independent part, the other one is time dependent part. Now, the question asked is square modulus of this wave function. What is square modulus? It is nothing but psi star psi. So now this is my psi. So take this psi and take the psi star, multiply. So what I am getting is a square modulus of the time dependent probability. Square modulus of the time dependent wave function. This probability is equal to square modulus of the time independent wave function. This probability becomes equal to this probability. Time dependent probability now becomes time independent probability. These two are equal when potential energy is independent of time. Okay, so the correct option for this question is option A. Right? Take it. Yeah. So question number 3. See, in 3 dimension, Hamiltonian operator is equal to, okay, 4 options are given. We need to identify which is the correct formula for Hamiltonian operator. If you see option 1, only 1 dimension is given, okay, along the x-axis, right? So this cannot be the answer because the question given clearly that in the question is given clearly that it is 3 dimension. Now here minus h bar square by 2m, yes, this part is correct. Del square, yes, kinetic. So this is kinetic energy operator. Okay, is correct. But d square by dx square, listen, this is not the potential energy operator. Okay, right? Because potential energy is not given here. So you should put simply V. Simply V. That is the only allowed way of writing Hamiltonian. Okay, nothing has mentioned about potential energy here. So instead of potential energy, if you write d square by dx square, it is wrong. Okay, because nothing has mentioned. So if you see this one, see, yes, this is correct. Kinetic energy part. Yes, this is a general symbol for the potential energy part. Yes, this should be the correct answer. Then if you see option D, yes, in option D, yes, minus h square by 8 pi square, this is correct. Okay, 1 dimension, yes, 3 dimension is there. That is also correct. This entire term corresponds to kinetic energy operator. What about the potential energy? Potential energy is not given here. Okay, potential energy is not given. Therefore, we cannot take this as an Hamiltonian operator. Okay, so the correct option for this question is option C. Right? Right, so this is question number 4. Choose the incorrect option, which is incorrect. Okay, L square, commutation of L square with LZ. We know very well. L square commute with LZ. LZ. L square commute with Lx. L square commute with Ly. Okay. L square commute with Lx, Ly, Lz. But Lx and Ly, okay, Lx, Ly, they do not commute. You will get the answer as IH cross into Lz. You know very well how to write. You should use cyclic rule. X, then Y. After Y, you should get Z. Okay. Then Ly, Lz. They do not commute. You will get IH cross into Y. After Y, you have Z. After Z, you should get X. Are you able to follow? Remember all the question. So, see the option A. Yes, L square, Lz, commute. Equal to 0 means commute. Yes, this is correct. And this is P is Px square, Px. You know very well. if an operator and its square are given, okay, then they commute with each other. This is a general formula. See, A operator, comma, A operator power any n value, it is 0. Whether you write A power n or A power n by A, in whatever direction you write, it is always 0. Then L square, Lx, yes, they commute equal to 0. Equal to 0 is given. Yes, that's correct. This is correct. Then what about option D? Y comma Py equal to minus IH cross. You know very well. See, X comma Px, they do not commute. You will get IH cross. Okay, you will get the answer as IH cross. X comma Px is IH cross. Similarly, Y comma Py should be plus IH cross, not minus. Not minus. Minus is given. Therefore, this is wrong. Okay, take 2. So the correct option for this question is option D. Right? So question number 5. The eigenfunction, the eigenvalue of d square by dx square. Some operator is given. For this operator, we need to find out the eigenvalue. Okay, the eigenvalue of this operator acting on the function psi is equal to 1 by 2 into sin 4x into cos 4x. Okay, so some function is given. Now we need to find out what is the eigenvalue of this operator acting on this function. Okay, so what to do? Listen, the wave function is given in a tricky way, that's all. What is that? 1 by 2 sin, you take this as theta, sin theta into cos theta. You know, there is a formula in trigonometry, 2 sin theta into cos theta can be written as sin 2 theta. That's the formula available. Okay, 2 sin theta into cos theta equal to sin 2 theta. Or I can write sin theta into cos theta equal to 1 by 2 into sin 2 theta. You can write like this. Okay, so see here, I have sin 4x and cos 4x. Right, so sin theta, cos theta can be written as, see, can be written as, so this can be written as 1 by 2 into sin 2 theta. This is theta. If I take this as theta, I should write sin 2 theta. So 2 into 4x, I'll get sin 8x. The wave function is nothing but 1 by 4 into sin 8x. Okay, instead of giving the wave function like this, it is given like this. So you should know, just by observing sin 4x, cos 4x, this formula should come to your mind. Okay, now, so this is the wave function. Now you have to differentiate 2 times. Okay, d square by dx square acting on the wave function psi is equal to. First we'll differentiate once. I will keep 1 d by dx as such. Now if I differentiate this, see, the 1 by 4 is a constant, keep it as such. Sin 8x, if you differentiate, you will get cos 8x. What is the coefficient of x? Coefficient of x is 8, so multiply this by 8. Okay, so since 8 is constant, you can take it out. Right, keep the 1 by 4 as such. Keep the 1 by 4 as such. Now, differentiate second time. Cos 8x, if you differentiate, you will get minus
sin x.
Minus sin 8x. And the coefficient of x is 8, so multiply this by 8 again. So you have 1 minus sin, 1 minus and 8, so just keep it out. So you get minus 8 8s are 64 into 1 by 4 into sin 8x. 1 by 4 sin 8x is the given function. See, 1 by 4 into sin 8x is the given function. And I got the same function again. Okay, so when you apply the operator on a function, we get the same function multiplied by some constant. That constant is nothing but eigenvalue. So eigenvalue for this operator acting on this function is minus 64. Okay, yeah. So this is question number 6. A quantum mechanical system exists in a state psi is equal to 1 by 2 psi 2x plus root 3 by 4 psi 4x. Here 1 by 2 is a coefficient and root 3 by 4 is another coefficient. So linear combination of two functions, psi 2 of x, psi 4 of x are given. This linear combination is taken as psi. And with infinite potential barrier 1D box. See, a quantum mechanical system exists in this state with the infinite potential barrier 1D box. So this is 1D box problem. The expectation value of energy is, and it is given that potential energy inside the box is 0. And E1 is nothing but h square by 8 ml square. Right? Yes, how to proceed? How to proceed this problem? Listen. So we need to find out the expectation value of energy. You know very well, under postulate 4, you might have seen this. Listen. Under postulate 4, the expectation value of energy is equal to, listen, psi 2 of x, psi 4 of x, these are all normalized wave functions, normalized eigenfunctions of Hamiltonian operator. Okay, in the case of 1D box. Okay. So first I'll write the formula. Formula is this. Okay, bra of psi. Okay, psi, say psi n of x, right, into, this is bra of psi, then the Hamiltonian operator, then ket of psi. Ket of psi divided by bra of psi into ket of psi. Okay, this is a general formula. Now, this is in the case of 1D box, the wave functions, that is psi 1, psi 2, psi 3, etc., all are normalized eigenfunctions. All are normalized eigenfunctions. Okay. Since it is normalized, the denominator quantity becomes equal to 1. Therefore, we will have only the numerator. And you know very well, if the wave function is given as a linear combination of two eigenfunctions, observe carefully. If the wave function is given as a linear combination of two eigenfunctions, right, then the average value of energy or expectation value of energy can be written as, summation square modulus of the coefficient of the ith function into eigenvalue of the ith function. What is meant by that? Listen, this is coefficient, this is eigenfunction. What is meant by that? Listen. So what is the operator we are using now? Hamiltonian operator. Listen, if you apply a Hamiltonian operator on nth state of 1D box, nth state function of 1D box, we get energy. Okay, what is that energy? N square h square over 8 ml square into the same function. Observe carefully, if you apply Hamiltonian operator on nth state of a nth state wave function of particle in 1D box, we'll get this eigenvalue. Okay, Hamiltonian operator will give an energy eigenvalue, correct? This is the energy formula into the same function. Okay. Now this quantity h square by 8 ml square is given as E1. That is the energy of the ground state. Okay, in the question it is given as E1. See here, it's given as E1. So what I am going to do, I'll take this as simply n square into E1 psi n of x. Okay, now what is the eigenvalue if I apply Hamiltonian operator on psi 2 of x? In the linear combination, psi 2 and psi 4 are taken. So first I will apply Hamiltonian operator on psi 2 of x. So n value is 2, put 2 here, you will get 4, 2 square is 4, so 4 E1 into psi 2 of x. Okay, now apply the Hamiltonian operator on the other function, that is psi 4 of x. If you apply Hamiltonian operator on psi 4, n value is 4, so 4 square is 16, so 16 times E1 into psi 4 of x. I am just using the general formula here. Now observe carefully, what is the coefficient? For the first function, coefficient is 1 by 2. Okay, there is no imaginary part. So you take the square. The square, 1 by 2 square is 1 by 4. Okay, into eigenvalue of psi 2x. For if you apply Hamiltonian operator on psi 2, I will get 4 into E1. That is the eigenvalue. So just multiply this by 4 into E1 plus. Then take the second quantity. Here the coefficient is square root of 3 by 4. take the square. Square will give you 3 by 4. Okay, into psi 4 of x. Eigenvalue of psi 4 of x. If you apply Hamiltonian operator on psi 4, I am getting 16 into E1 as the eigenvalue. Substitute that eigenvalue here, 16 into E1. Now just simplify it. 4 4 cancel. 1 4s are 4. 4 4s are 16. So I will get E1 here, and here 4 3s are 12. 12 E1. So the total is 13 E1. Yes, this is the expectation value of energy of a particle present in this state psi. In this state psi, where psi is given as a linear combination of two eigenfunctions, psi 2 and psi 4. Okay, take note. So the correct option for this question is option D, 13 times E1. Right? Take note. And this is the idea. Take note. Yeah, this is question number 7. Okay. An electron is confined in a metallic nanowire of length 10 angstrom unit. Length is given. If the potential energy inside the nanowire is 0, inside the nanowire potential is 0, then the 0 point energy of the electron is. In the question, we need to find out the 0 point energy of the electron. And we want the answer in electron volt. Given, assume the nanowire as a 1D box with infinite potential barrier at the terminals. So you take a nanowire, and at the terminal we have infinite potential energy. Therefore electrons cannot jump out. That's the meaning. Okay, now how to find 0 point energy of this system? Okay, listen. This is actually easy, but you need to remember this particular formula. Listen, you know very well, in the case of 1D box, for one-dimensional box, okay, you know the formula, energy formula for 1D box. Energy depends on the quantum number n, which is equal to n square times h square by 8ml square. This we know, right? And observe this, this is very important. If we substitute the proper value of h, mass of, since electron is given, correct? Particle is electron, right? If you substitute these values properly, you will get n square into 37.64 by L square. This value becomes like this. Here, one important conditions are there. Two important conditions. What are the conditions when we should use this formula? Listen, this formula is applicable for electron. If particle is electron, you can use. Second one, length should be in angstrom unit. Length should be in angstrom unit here, so that you will get the energy directly in electron volt. Observe carefully, use this formula. If you use this formula, you will get energy directly in electron volt. But there is a condition. If you want to use this formula, there are two conditions. What are they? The particle should be electron here, and length should be in angstrom unit. If length is suppose given in nanometer, you should convert into angstrom unit and then substitute. That's all. Simple. So now, listen. In the question they are asking 0 point energy of the electron. What is 0 point energy? 0 point energy is nothing but
N value once.
Yes, the lowest value of energy. Lowest value of energy from quantum mechanics. Okay, that's nothing but E1. Right? So put in the place of n you put 1 here. So you'll get 1 square is 1 into 37.64 divided by L value is given 10 angstrom unit. See, L is given in angstrom unit. L should be in angstrom unit. This is given directly in angstrom unit. So just put that value here. L square means 10 into 10. The value should be in angstrom unit. Okay, so 10 into 10 is 100. 37.64 by 100 will give me 0.3764 electron volt. Okay, so the correct option for this question is yes, option D. Okay, I'm sorry here, I have given wrongly the and option is minus, it is actually plus. Okay, take. Suppose
x square 8ml square adile ondru sir joule.
Yeah. Otherwise, you just take this value, multiply this by 1.60 to 10 power minus 19 coulomb. You know, 1 electron volt equal to 1.602 into 10 to the power minus 19 joules. Okay, so if you multiply this value by this, you will get the answer in joule. So E1 equal to 0.3764 times 1.602 into 10 power minus 19, you will get the answer in joule. Okay, you need to multiply this. Okay, right, take it. So if you multiply these two, you will get the answer as 0.6029 into 10 to the power minus 19 joule, or multiply this by 10, you will get 6.029 and divide this by 10, so you will get 10 power minus 20 joule. This is the answer, the corresponding answer in joule. Okay, next. Question number 8. See, for a particle in 1D box with infinite potential barrier, so this is normal 1D box, the energy gap between n equal to 4 and n equal to 5 level. See, energy gap delta E between n equal to 4 and n equal to 5 level is given. How much? Is 900 joules. And the question asked here is, the energy of the n equal to 2 level is. What is the energy of the n equal to 2 level? Okay, this is the question. Yes, how to proceed? It's very simple. N equal to 4 and n equal to 5 are adjacent level. Okay, you know very well the energy gap between adjacent level, okay, is equal to 2n plus 1 into h square by 8ml square. Okay, and this is given as 9, and okay, now the gap, adjacent level gap between n equal to 4 and n equal to 5, n equal to 4 and n equal to 5. Listen, you should always choose the lower value here. Put the lower value here. What is the lower value? 4. Put 4 here. 4 into 2, 8. 8 plus 1, 9 into h square by 8ml square equal to 900 joules. Okay, now what to do? Just divide this by 9. So, what's the value of h square by 8ml square? H square by 8ml square is 100 joules. This is the value of h square by 8ml square. Now, what we need to find out? Energy of the n equal to level. Energy of the n equal to 2 level equal to n square. This is general formula, right? N square into h square by 8ml square. N value is 2 now. So, 2 square is 4. H square by 8ml square is 100. So, 4 into 100, you will get the answer is 400 joules. Okay? The answer is 400 joules. Very simple. Take the general formula, put n equal to 2 here, and h square by 8ml square value we found out. Substitute that value here. So, 4 into 100 is equal to 400 joules. Right? Take. So, question number 9. The energy of a particle confined in a cubical box. So, now the box is cubical box with infinite potential barrier outside, normal cubical box problem. Energy is given. Okay, so energy is given as 38 into h square by 8ml square. And the question asked here is, degree of degeneracy associated with this level is. Okay, we need to find out degeneracy. Yeah, listen, how to proceed? See, how to proceed? Since there is cubical box problem, energy is given by the formula nx square plus ny square plus nz square times h square by 8ml square. Now the energy is given as 38 into h square by 8ml square. So these two cancel. Now nx square, ny square, nz square, the sum should be equal to 38. So we need to select some integer values, positive integer values, such that the sum of those square values should give you the answer is 38. So what combinations will there? Nx, ny, nz. Okay, combination number 1. You take the values as 6, 1, 1. 6 square is 36. 1 square is 1, 1 square 1. If you add, you will get 38. And here we have two more possibilities. What is that? 611 or 161. Third one, 116. All these three will give same energy, right? Now, apart from this, we have other values. What are they? 2,
5,
3, 5. Correct? 2, 3, 5. Am I right?
Yes.
2 square is 4. 3 square is 9. 9 plus 4 is 13. 5 square is 25. 25 plus 13 is 38. Yes, but here all the three numbers are different, so you have 6 possibilities here. This is 1. Then next possibility 2, 5, 3. Next possibility keep 5 in front. 5, 2, 3. Then 5, 3, 2. Then keep 3 first. 3, 2, 5. Then 3, 5, 2. Okay, so we have 9 possibilities. Apart from this, no other values, okay, will match with this equation. Right? So I have 9 possibilities. Therefore, degree of degeneracy associated with the energy level is 9. So the correct option for this question, is option B. Right? This is question number 10. Just go through the question. What is given? A particle confined in a 1D box has a constant potential energy V is equal to 0.1 times Z, where Z is the 0 point energy. Okay, see what is given in the problem. 1D box is given and potential energy, constant potential energy. Potential energy is constant, but it is not 0. Some value is given. Potential energy equal to 0.1 times Z, where Z is nothing but 0 point energy. You know, for particle in 1D box, 0 point energy, okay, 0 point energy is equal to h square by 8 ml square. We know that. This is 0 point energy. Okay, what is potential energy given? Potential is 0.1 times in the Z value. Right. Now, the energy of the particle in n is equal to 5 level is. Okay. What is the energy of the particle in n equal to 5? You know very well. Energy of the particle in nth level is equal to n square times E1. What is E1? E1 is nothing but 0 point energy. So n square into Z. Okay, this is the general formula for En. Now in the problem they are asking energy of the n equal to 5 level. So in the place of n we put 5. So energy of the n, okay, one more thing, I'm sorry. This is the energy formula if potential energy is 0, correct?
Yes, sir.
This is the energy formula if potential energy is 0. But now potential energy is not 0. So what to do? But it is a constant. Whenever potential energy is constant, you add that value as such in the energy formula. Therefore, En is equal to n square into Z plus 0.1 into Z. This is the formula. Okay, this is actually a translational kinetic energy and this is the potential energy. Now you take Z as common, so En equal to n square plus 0.1 times Z. Now in the question they are asking energy of the n equal to 5 level. So if we put n equal to 5 here, what we get? E5 equal to 5 square is 25 plus 0.1 into Z. So this is 25.1 into Z. This is the energy of the n equal to 5 level. So the correct option for this question is option D, 25.1. Okay, take them. See this question, question number 11. For a particle in 1D box, okay, at some state, wave function is given, right? And this is the limit, x equal to 0 to x equal to L. Wave function becomes 0 at x equal to 0. Wave function becomes 0 at x equal to L. And wave function increases in the beginning, okay, and becomes 0 at L by 2. Then it becomes minus and reaches value 0 at x equal to L. Okay, now see we have one node here. There is one node, right? What they are asking? The value of d square psi. Psi is plotted in y-axis and x-axis we have x variable. Okay. If we plot d square psi by dx square, we need to find out d square psi by dx square at x equal to L by 2 at the middle of the box. X equal to L by 2 means middle. At the middle of the box, what is the value of d square psi by dx square? Okay, yes. Then how to answer this question? It's very simple. What to do? We have to differentiate this 2 times. Okay, and put the value equal to L by 2. Isn't we know very well the general formula for a 1D box is square root of 2 by L, and here the wave function has one node, therefore the wave function is supposed to be psi 2. Okay, if there is one node, wave function is supposed to be psi 2. Right, now listen, because psi 1 has one node or 0 node, psi 2 has one node, psi 3 has 2 node, so if it is psi n, there will be n minus 1 node. Okay. So since we have one node, so the wave function is supposed to be psi 2. For psi 2, wave function is square root of 2 by L into sine 2 pi by L into x. In the place of n, you put 2. Now differentiate this 2 times. Okay. First time I will differentiate this with respect to x. What will I get? Square root of 2 by L remains as such. Sine, you take this as a. Sine ax, if you differentiate, yes, you will get cos ax, and the coefficient of x is 2 pi by L, so I will write that 2 pi by L as such. Okay, this is differentiation once. Then differentiate this again. D square psi 2 by dx square equal to, these are all constants, just keep it out, square root of 2 by L into 2 pi by L, keep them out. Then differential of this will give me minus sine 2 pi by L into x, and the coefficient of x is 2 pi by L. So what we get is minus square root of 2 by L into 2 pi by L the whole square into sine 2 pi by L into x. This is after second derivation. Now what is the value of the second derivative of the wave function at x is equal to L by 2 at the middle of the box? Put x equal to L by 2 here. If you put L by 2, L cancel, 2 cancel, and with sine pi, you know very well, sine all pi values are 0. So this becomes 0, therefore the entire value becomes 0. Okay. So second derivative value at x equal to L by 2 is 0. Remember, you know very well, if second derivative is 0, what does it indicate? There is a point of inflection. This point is called point of inflection. What is happening here? The open downward parabola become open upward. Okay, so at this point, the nature of the wave function changes, so it is called point of inflection. You know very well, at the point of inflection, second derivative value should be 0. Yes, second derivative is 0 here. Right? So the correct option for this question is option C. Okay, take it. This is question number 12. For a particle in 1D box, the probability of finding the particle in the limit, okay, L by 4 to 3L by 4 at the fourth excited state is particle in 1D box. It is given fourth excited state. Listen, n equal to 1 is the ground state. Okay, n equal to 2 is the first excited state, second excited state, third excited state, and this is fourth excited state. N equal to 1 is ground state, first excited, second excited, third excited, this is fourth excited. So fourth excited state means n equal to 5. N equal to 5. It is an odd number, and you know very well, this is the formula of probability. Listen, and this probability between this range is very, very important because it's a constant, right? You need to remember that. Probability in the limit L by 4 to 3L by 4. Okay, in this range, probability, it has two different values. What is that? Probability equal to 1 by 2 if n is equal to an even number. probability equal to 1 by 2 plus minus 1 power k by 2 by n pi, by n pi if n is an odd number. Okay, yes, in our case n is an odd number. So you must use this formula. Therefore, probability in this range is equal to 1 by 2 plus n value is 5, so 5 into pi minus 1 power. What is k? Listen, 2k plus 1 is equal to n. Okay, so 2k plus 1, n value is 5, put 5 here, bring the plus 1 to the right hand side, so 2k equal to 4, k is equal to 2. So if I put k equal to 2 here, minus 1 power 2, minus 1 square is plus 1, so the answer is 1 by 2 plus 1 by 5 into pi. This is the answer. Okay, this is the probability, right, of finding the particle in the range L by 4 to 3L by 4 in n equal to 5 level. Okay, take it. So the correct option for this question is 1 by 2 plus 1 by 5 by pi. Okay, take it.